Yeah. This video is about what to do if you have a truss that isn't 45 degrees, it's 60 degrees and 30 degrees or something else. This truss that I'm about to look at can be found in the Truss Practice Problems 4.5 under Uploaded Media on Elms. Okay, so first I'm going to start with the joints method. Like always, I'm going to first make sure I have my reaction forces. I do, good. And then I'm going to look for easy joints. I always like to start on one side so it makes it easy for me. And normally I like to stop in the top left corner, but that is not an easy joint because it's got uh, multiple unknown members. So I'm going to start in the bottom left joint. So I'm going to redraw it. Okay, there's A and there's B. Well, by using the sum of forces in the y direction, that is going to be just uh, A. So I know that A is going to be equal to 0 kips. If it's ever by itself like that, it's just going to be 0. We can say the same thing for the x direction. Sum of the forces in the x direction is equal to 0. It's equal to, it's just, oh, sorry, it's not B, it's D. It's just D, so D is also going to be 0. Okay, now that I know A, I can move on to joint 1. I'll box these first. Okay, let's do joint 1. Okay, so let's do the sum of the forces in the y direction. It's equal to 0. And what do I have? Well, I've got 4 kips coming down, so I can say negative 4 kips. I know that A is 0, so I can just forget about that for right now. And that's going to leave me with C. It's a diagonal member, so it's going to be CY. So I'm going to say plus CY. And I'm assuming, for the sake of solving the problem, that CY is going up, which I think will make sense because it's got to counteract this 4 kips. Okay, so if those are the only two forces in the y direction, then I can say move this 4 kips over, and I can say plus 4 kips plus 4 kips. I can say CY is equal to 4 kips. Okay, now here's where it gets different from if the here's where it is different from if the truss was 45 degrees, 60 degrees, 30 degrees. So I always think it helps to redraw the triangle. So I'm going to say that's C, and then I've got CY and CX. And by the way, I got that CY is 4 kips. That's positive 4 kips. So my assumption was correct. And my assumption was that CY is going in the opposite direction of the 4 kips. So the 4 kips is going down, CY is the opposite, so CY must be going up against it. So I know that C is going to look like that. I can say CY is like this, and CX is like this. And now I gotta add my angles here. This is 60, this is 30. So I know CY is 4 kips. So using that, I've got to try and get C and CX. Now, if this triangle was 45, 45, 90, I could just say CX is equal to CY. But I can't do that here because it's not, the sides aren't equal. But what I can do is use some trigonometry to get C and CX. So first, let's get C. I'm going to think about SOHCAHTOA, and I'm going to think about something that involves this hypotenuse. I can say, what if I said sine of 60 degrees is so sine is equal to opposite over hypotenuse. So I could say sine of 60 degrees is equal to the opposite, which is CY, over the hypotenuse, which is C. So now I can multiply both sides by C times C times C and say C times sine 60 is equal to CY. Can divide by sine 60, divide by sine 60, and I can say C is going to be equal to CY divided by sine 60. Okay, and I know that CY is 4 kips, so 4 C equals 4 kips divided by sine 60. And that means that I can use the calculator now. And always make sure with your calculator, whether it's on your, whether whatever type of calculator you have, that it's in degree mode. So see, on my calculator, I can press this degree button and say, make sure I'm in degree mode, not in radian. I think on the graphing calculators, up in the top area here, there's a button for mode where you can check that. Okay, so now I can say 4 divided by sine 60. Okay, C is going to be 4.62 kips. And let's see, I can see based on the direction I found for C that C is going in towards the point, and that means that C is in compression. So I can say C equals 4.62 kips, and it's in compression. Next, I need to do the sum of forces in the x direction. Let's say sum of forces in the x direction is equal to 0. It's equal to, let's see, there's B and there's CX. Now, I don't know which direction B is in, but I'm just going to assume it's positive for now. And I know that CX is going to the left, so I'm going to say that's negative. So I'm going to say B minus BX is equal to 0. And in order to move forward here, I'm going to need to figure out what CX is using this triangle. There are a couple methods you could do. You could use the Pythagorean theorem, or I'm going to practice using my trigonometry some more. So I can say, all right, I know what C is. C is 4.62 kips. And let me add that triangle. 4.62 kips. So now let's do sine again, because I like sine. So let's say sine of 30 degrees is equal to opposite over hypotenuse. So sine of 30 degrees is equal to C of x, the opposite over the hypotenuse. So go to CX over the hypotenuse C. And then I can multiply by c, cx is equal to c times sine 30. Cx is equal to 4.62 kips times sine 30 degrees. Cx is equal to, let's see, 4.62 times sine 30. 2.31. Cx is equal to 2.31 kips. So now I can plug that back into this equation, and I can say 0 is equal to b minus 2.31 kips, plus 2.31 plus 2.31. So b is equal to 2.31 kips. You got a positive answer, so that means my assumption was correct. And my assumption in the equation was that b is positive, so it's going in the opposite direction of the c of x, which is negative. I know c of x is going to the left, so b must be going to the right. Okay. And if b is going to the right, that means it's going away from the point, which means that it is in tangent.